So today we're going to be talking about work. This is a tier 4 assignment for me, Boris. Simple. So work is a scalar. Work is a scalar that is the dot product of two vectors of force and displacement times delta d. So that is what work is. So force is simply a scalar, work is simply a scalar, a dot product of two vectors. So there's another way. So that what I just wrote would be for linear force. So force that is either at a 90-degree angle, or work that is either like this or like this. So when an angle is added in, we take the cosine. So let's say a crane is lifting a piano at a 30-degree incline, or a pulley system is lifting a piano at 30 degrees. What we have to do after this is take force times displacement times the cosine of the angle, which is cosine x. Then we have the ability to solve for things at an incline. Now let's incorporate all of what I've just mumbled about into a problem. So the problem goes, we have a 20,000 kilogram car is moving up a 5-degree hill and the hill is 290 meters. Working against the car is 524 newtons of kinetic force. So mu k is equal to that. So since there's no acceleration, this is also the work. So now, getting back to the problem. The problem asks how much force needs to be acting upon the car. Great car, anyone would want to buy it. Hey, it's a bus. How much for there to be a positive output of 150 kilojoules. Kilojoules are the unit work is measured in. So, in order to find this, we have to start from the beginning. We have to take delta D, which is equal to 290, and the force of friction, because we have to start from what we're given, and multiply that by 524. Some math done beforehand, negative 524, gives us negative 151,960 kilojoules. Just joules. So with this number, what we go on to do is that we need an excess. So right now we have negative 1, and we have to add an X amount to create here, let me change colored pens. See if this works better. And to equal so X we figure out to be equal to 301,960 kilojoules is the number we're looking for the force the car applies. So, from here, we have 120, which is the mass, times 290, displacement, times cosine of 5 degrees, times the cosine of 5, and then we have to incorporate a third, times y. Y is the acceleration we need to find, because when we have these two, we get force. Since we don't know what y is, we can't know what the force is. But we do know that the total work is equal to 301,960. 301,960. So we know that's the total joules we're looking for. So once we get down to work, we end up figuring out that y, this acceleration, is equal to y cosine x is equal to 0.87. So the acceleration which we're looking for. One sec, I'll be right back. So what we end up getting is pretty much the same thing. So y ends up being 0.873. That's the acceleration. So now we have all of the variables, we have the work we need, and we're set for everything else.